Now see, complex numbers in quadratic equation. If we need to solve x square plus 1 equals to 0, then we can say x square equals to minus 1. X equals to square root of minus 1. And we were not able to solve it. Such situations we were not able to solve. So that were creating problem to us. Or one more example I am showing you. There was one equation x square plus 2x plus 3. We need to solve this. Then what we could do with such conditions? So in this case, we need to solve x equals to minus b plus minus under root b square minus 4ac upon 2a. Over here, A, B, C selection. Hope you remember A, B, C. This is said as quadratic formula or Sridharacharya's formula. So A is 1, B is 2, and C is 3. So minus 2 plus minus under root 2 square minus 4 into A is 1 into C is 3 upon 2A. So minus 2 plus minus under root 4 minus 12 upon 2. So it comes minus 2 plus minus under root minus 8 upon 2. Now see, this is negative, and we used to say in this case or this case, root of negative is not possible. Therefore, we cannot solve it further. Or the roots of the quadratic equation were imaginary. We also used to say if d is less than 0. If d is less than 0, then quadratic equation has no real roots. Now that no real roots condition we need to study over here. So now another thing which we need to study is to understand a complex number. First of all, we must try to understand what is square root of negative times of unity. Square root of negative times of unity is known as I. I can be said as iota. So now, as in the previous step, I was showing you x square plus 1 equals to 0, and x square, x value we were not able to calculate. Now x square will be minus 1, and x equals to under root minus 1. Here plus minus used to come, so plus minus I. This is the value of x. This is said as the value of x over here. So now another thing is this, means till class 10 we were not knowing, but now we have got idea that anything like x could have imaginary value also. So that is said as I. Now just try to see some of the concepts. Just now I have told you I, that is iota, it will be having value as square root of negative times of unity. Square root of negative times of unity is said as iota. If we will square both the sides, it will become I square, and I square will be minus 1. We have got I as square root of negative times of unity. So I square will be equals to minus 1. The value of I square over here will be minus 1. If we need to calculate the value of I to power 3, then it will be I square into I. And the value of I square is minus 1 into I, that is minus I. So value of I cube will be minus I. In case we have I to power 4. So I to the power 4 will be I square into I square. So that means minus 1 into minus 1. That could be said as 1. So we have got the values. The value of I we will never use. I square will be equals to minus 1. I cube will be minus I, and I to power 4 will be 1. These values you need to remember, because with these values we are going to calculate the different things. Now this is iota, imaginary. Now whenever we are going for a complex number, so what I could say, a number in the form of a plus ib. A number in the form of a plus ib is known as complex number. A number in the form of a plus ib is known as complex number, where there are two things, a and b, because I is standing for the iota, a and b. A is known as real part of the complex number. And B is known as imaginary part of complex number, right? So A is the real part of complex number and B is the imaginary part of complex number. A complex number mainly we will try to represent with the symbol Z. Z is equals to A plus IB. This is said as complex number, which is A plus IB. Now this all was something new, so that new you are understanding, but yes, whenever we used to study new things, we find something like something is different from the studies. Now we will be as usual to the previous class. I try to make it very simple, very easy. So first thing I'm showing, like somewhere it is written I to power 23. Write it in the form of a complex number. So we need to simplify it. To simplify it, what I'll do, this is I to the power 22 into I. Even powers we will make separate. Now you know very well in multiply powers will get added. We know it very well that in multiplication powers will get added. So now it will be I to power 2 to whole power 11 into I. I to power 2 can be written as minus 1 to power 11 into I. Minus 1 to power 11 will be minus 1 into I. That is minus 1. So complex form answer 0 minus 1 I. This is a complex number. Always you need to give answer of anything in form of complex number in this particular chapter. If it is not like if it is coming 2, so you will be writing 2 plus 0I. So that things you need to keep in mind. One question is given, this also you must try to understand. It is 4x plus I times 3x minus y. This is equals to 3 plus I minus 6. Minus 6, sorry, minus 3. Now see, real part will be equals to real part. When we will compare it, real part will be equals to the real part and imaginary part will be equals to the imaginary part. Means 4x will be equals to 3. That means x will be equals to 3 by 4. 3 by minus, sorry, 3x minus y. Minus 6, x value is 3 by 4. 3 into 3 by 4 minus y equals to minus 6. So 9 by 4 plus 6 equals to y. 4, 24. So y is equals to 33 upon 4. So likewise, we can calculate the values. Now, some of the properties of the complex number we must be knowing. See, algebraic properties of complex number. Algebraic properties of complex numbers. In this addition of two complex numbers. Now addition of 2 or 3 complex numbers. First property is closure law. What is closure law? The sum of two complex numbers will be a complex number. Sum of two complex numbers will be a complex number. Like in the junior classes 6, 7, 8, we used to study sum of two natural numbers will be a natural number, sum of two real numbers will be a real number, sum of two integers will be integers. So now same is closure law. It is sum of two complex numbers will be a complex number. Means Z1 plus Z2 will be Z. sum of two complex numbers is a complex number. We can show it like this also. 2 plus 3i plus 3 minus I will be 3 plus 2, 5 plus 2i. So this is the condition that yes, sum of two complex numbers is coming a complex number. Next property is said as commutative law. What is commutative law? This is Z1. Again, these all the properties we have studied in the junior classes. Z1 plus Z2 can be written as Z2 plus Z1. Means the sum of two complex numbers. First one we are writing first and second one second. If opposite, second one we are writing first and first one second, then it remains same. As in the previous classes we have said, A plus B equals to B plus A. So same base, Z1 plus Z2 will be equals to Z2 plus Z1. This is said as the commutative law. Now third property, it is associative law. Now associative law, but it is try to see Z1 plus Z2 plus Z3 is for sure Z1 plus Z2 plus Z3. But now there will be a game of the brackets. Z1 plus Z2 plus Z3 will be equal to Z1 plus Z2 plus Z3. This is said as associative law. Fourth property. This is said as additive identity. Additive identity means if we are adding Z to a complex number which is 0, then it remains Z. Means what number should be added to the complex number so that it remains same. So that is 0. This is said as additive identity of the complex number Z. Last property, additive inverse. Additive inverse means try to see like what must be added to A so that I must get result 0, that is minus A. So that only is A plus IB. What must be added to this? Minus A minus IB. So that the result must be 0. So this is said as additive inverse. Now, I think sufficient. One example, one properties segment we have completed. There are many. Rest of the properties we will discuss tomorrow. Now, some of the questions I must do because identities are to remember, and questions will be comparatively very easy. Let us see. First question is, it is 5i into minus 3 upon 5i. So when we will simplify it, 5i into minus will come in front, 3 upon 5i. 5 to 5 will get cancelled, minus 3i square. And the value of I square, just now I have taught you, the value of I square is minus 1. So it will be minus 3 into minus 1. So it will be 3. Now complex answer z is equals to 3 plus 0i. This is said as the answer, because answer we need to give also always in the form of a plus I b. Answer must be in the form of a plus ib. Its second part I am going to do. It is I to power 9 plus I to power 19. So I to power 9 can be written as I to power 8 into I plus I to power 18 into I. I to power 8 can be written as I to power 4 to whole square into I to power 2 to whole power 9 into I to power 4 is 1 square into I plus minus 1 to whole power 9 into I. It will be 1 into I minus 1 into I. That is I minus I. It will be 0 or 0 plus 0i. Third, if the question comes I to the power minus 39, then it could be written as 1 upon I to the power 39. If it is I to power 40 means 4 multiple, that will be much better. So I'm multiplying and dividing by I. I multiply, I divide. It will be I upon I to the power 40. I could write I upon I to the power 4 to whole power 10. I upon I to the power 4 is 1. 1 to power 10 will be 1 only. So I upon 1, or it will be 0 plus 1i. See, 1 minus I to whole power 4. Till date, we are not knowing how to do for power 4. So what I'm doing, 1 minus I to whole square to whole square. So it will be a minus b to whole square, a square plus b square minus 2ab to whole square. It will become 1 minus I square is minus 1, na? Minus 2i to whole square. 1 to 1 will get cancelled. Minus 2i to whole square. So it will be 4i square. I square we know it will be minus 1. Okay, into 4. 1 step extra. Minus 4 plus 0i. This will be the complex form answer. So I think now you are able to understand what to do in this kind of questions. This is, we are writing the answer in the form of complex number. If you are not writing, then also it is not a big issue. But I feel always give answer in the complex form. Now, which one I must do? 10th I'm doing. it will be -2 minus 1 by 3i whole cube. Keep in mind, mathematics you won't be able to understand if you are not practicing daily. Without daily practice, maths is not at all possible. See, first step, I'm taking minus sign common. When I'm taking minus common, but it will become 2 plus 1 upon 3i to whole cube. Minus का cube will remain minus 2 plus 1 upon 3i whole cube. If you want to take LCM, then also that you could do. This is, I'm explaining you everything what you could do. Without taking LCM also we can do. 3, I have taken LCM. 6 plus I whole cube. Now minus 1 by 3 is outside. It will become 6 plus I to whole cube. Sorry, its cube is also there. So 1 upon 27. Now A cube plus B cube plus 3A square B plus 3A B square. Hope you remember this identity. So minus 1 upon 27. 6 cube, I remember it is 216. Minus I plus 36 into 308 I minus I square will make minus 1. Okay, minus 1 I'm writing like this in the first step. So it will be minus 1 upon 27, 216 minus 18, 196. Sorry, 198 it will be, na? 198 minus 107 I. So over here we can leave for 27, we can take inside. So it will be minus 198 upon 27 plus 107 upon 120, sorry, only 27. I. So this will be the answer of the question number 10. It was not. If possible, we can simplify it also. So now, hope you are able to understand this and you will be able to do this question also. Now, next thing comes, this is said as multiplicative inverse. Multiplicative inverse is like a simple concept. First of all, I'm trying to explain you. 2. Its multiplicative inverse will be something which gives me the result as 1. The number with what we must multiply to the given thing so that we must get result as 1. So it will be 1 upon 2. And now for complex number, when you are going, it will be like a question is given. 2 plus I. So its multiplicative inverse will be 1 upon 2 plus I. But now one thing you must keep in mind, somebody is raising hand. Just after this I will discuss. Uh, we cannot leave square root or I in the denominator. In class 9th we used to say, 9th में हमने कहा था ना स्क्वायर रूट डिनोमिनेटर में नहीं होना चाहिए, वैसे ही अब हम कह दे रहे हैं आई डिनोमिनेटर में नहीं होना चाहिए. सो 2 माइनस आई रेशनलाइज कर रहे हैं, तो रेशनलाइज करना ही तो ये होता है, विद द अपोजिट साइन वी नीड टू मल्टीप्लाई एंड डिवाइड. सो इट विल बी 2 माइनस आई अपॉन 2 स्क्वायर माइनस आई स्क्वायर. सो इट विल बी 2 minus I upon 4 minus I square will be minus 1. So 2 minus I upon 5. So 2 by 5 minus 1 upon 5I. This will be the complex number that is multiplicative inverse of this. So I think now you will be able to understand it. Now let me see, somebody was raising hand. Prameet. See beta, one of the student has told me that I have made one mistake. So it was 108 minus 1 will be plus 107. By mistake, I have written minus 107. So it will be negative. Now, correction I'm making over here. So it is positive. This one will become negative, and this will also be negative. So answer will be this. So that was a mistake which I have made. So you must be able to see this also, and I suppose you will not do such mistake. Ramit, see one more question of multiplicative inverse I am doing. This is simply I. So its multiplicative inverse will be 1 upon I. But as we know very well, I cannot be left in the denominator. So what I need to do, 1 upon I multiply, I divide. It will be I upon I square. That is I upon minus 1 or minus I. I can write 0 minus I. So two simple questions I have tried to do so that you must be able to understand it. Now see, after this now we have a complex number. Complex number can be said as Z is equals to A plus IB. This we need to represent on the Cartesian plane or organ plane. I'm writing Z equals to X plus IY. Now you will be able to understand better. For sure, there will be a point XY. Like this is the point X comma Y. This point I'm saying P. If we'll join this, then this is representing the complex conditions on the Cartesian plane or organ plane. Now, if you want to calculate its distance from O R is equals to under root, origin is 0, 0. So it will be x minus 0 to whole square plus y minus 0 to whole square. That is R is equals to under root x square plus y square. So we have got idea that the complex number can be represented in the Cartesian plane. Its conditions also I am showing you, like its distance, OP distance is said as R. This R is also known as modulus. Modulus of the complex number. This is said as modulus of the complex number. Modulus of complex number, we can represent mod z. This only is known as R. This is under root x square plus y square. If for this we need to calculate, then it will be mod z or R will be under root a square plus b square. If a complex number is given z is equals to 2 plus 3i, then its mod will be under root 2 square plus 3 square, under root 4 plus 9, under root 13. Whereas if we are going z is equals to minus root 3 plus I, that is mod z will be under root minus 3 to whole square, minus root 3, sorry, into I coefficient will be 1. So it will be plus 1 square. So minus root 3 to whole square will be plus 3. Negative square will be positive, plus 1. So it will be under root 4, that could be said as 2. So modulus of this complex number will be 2. So some of the examples I have taken to make you understand how to calculate the modulus or mod of a given complex number. So now I think you are able to understand how to represent any complex number in the organ plane. After representing it, if we need to calculate its modulus, we can easily calculate. Now after calculating modulus, now they may say us to calculate this angle theta. Now the angle theta is known as argument. Argument of a complex number. This is theta. Directly theta cannot be calculated, so I can calculate tan theta. Now try to see tan theta will be perpendicular upon base. This distance will be x. This distance will be y. So tan theta is equals to perpendicular upon base, that is y upon x. For a and b1, tan theta will be b upon b. So likewise we can calculate. Like one question I'm taking, with which we will try to calculate the argument of the complex number. So that I'm taking z is equals to 1 plus root 3i. Its modulus and argument we are calculating. So first of all, modulus mod z will be under root 1 square plus root 3 to whole square under root 1 plus 3 under root 4, that will be 2. This is the modulus. Now argument we are calculating. So tan theta is b upon a. B is the coefficient of I, that is root 3, and a is real part, that is 1. A equals to 1, b equals to root 3. Tan theta is equals to b upon a na. So we are getting tan theta equals to root 3. Tan theta equals to root 3. This happens tan theta equals to 10. Root 3 is 1060. In radians, we used to write it pi by 3. In radians, we used to write it pi by 3 radians. So theta equals to pi by 3. So argument is pi by 3 and modulus is 2. So in the next exercise, we need to calculate modulus and argument. So see this once, then you will be able to say something if you have got any confusion. So first of all, see, then I'll see your doubts. Three things for it. For a given complex number set, we can calculate three things for it. First thing is said as mod or modulus. Modulus is under root a square plus b square. Under root a square plus b square is said as modulus. A is this, the real part of the complex number. B is this, the imaginary part of the complex number. Then we need to calculate argument. We can say theta. So tan theta is equals to b upon a. Tan theta is b upon a. After that, next thing comes modulus is represented with the symbol r also. Polar form. Polar form is r cos theta plus I sin theta. These are the three things which they might ask us any of the time, that what has to be done. Now, let me explain you in the best way. I'm taking one question that might make you understand better. So z is equals to, which question I've taken earlier? 2 plus 3. Fine. Now I'm taking z is equals to 1 plus under root 3i. Now see, we need to calculate modulus. R or mod z is equals to under root a square plus b square. A is equals to 1, b equals to root 3. So it will be a is 1 square plus b is root 3 to whole square. 1 plus 3 under root 4. That is then tan theta is equals to b upon a. Hope you remember this also. Here is the formula. Now tan theta is equals to b. B is root 3 and a is 1. So tan theta will be root 3 or theta. Theta is set as argument. Now root 3 in 10 is the value of 1060. And let me remind you, 60 degree from class 10. Now we need to convert it into radians. So pi upon 180 we need to multiply 6, 3. So it will be pi by 3. Theta, that is argument, is pi by 3. Now if we need to write polar form is r cos theta plus I sin theta. R is 2. Just now we have calculated. So 2 cos pi by 3 plus I sin pi by 3. This is said as the polar form of the complex number given 1 plus root 3i. Polar form is the another way to write the complex number. We cannot put the value of cos pi by 3 and sin pi by 3. This whole is said as the polar form of the complex number. This is the polar form of the complex number. So I think you will be able to write it. One more example I'm taking. With that, I suppose you all will be able to understand the topic in the best manner. So this I'm taking more simple question I'm taking. Z is equals to 1 plus I. This says me A is equals to 1 as well as B equals to 1. So R is equals to under root A square plus B square. That is under root 1 square plus 1 square. That is root 2. After R, we need to calculate tan theta. Exactly, we need to calculate theta, but for that tan theta is equals to B upon A. So tan theta equals to B upon A means tan theta is equals to 1 upon 1. So theta equals to pi by 4. Now we have calculated R, we have calculated theta. Now polar form. R cos theta plus I sin theta. That is R is under root 2 cos pi by 4 plus I sin pi by 4. This will be the polar form of the given complex number. So I think now you will be able to do. So in this manner, you will be able to do the questions of the next exercise. Now, exercise 5.2 will be very much possible for you, but there will be one confusion. Now, let us discuss about that confusion. So there could be a special case could be there taking with purple color. A, B, theta. See, presently we are doing if A and B both are positive. A and B both are positive. In that case, theta remains theta. If A and B both are positive, then theta remains theta. Now, next case could be if in case A is negative and B is positive. Likewise, A is positive, B is negative. And likewise, at the end, A and B both are negative. In this case, will be what? In this case, argument that is theta will be what? So for this, we are going to discuss So if A is negative, B is positive, then it will be phi minus theta. And A positive, B negative, then theta minus phi. And if both negative, then minus theta. These are the four situations which we need to take care. Now, one example I'm taking in which I'll be able to make you understand about the condition when any one of the two will be negative. So question I'm taking from the book. Second question. See, here it is given z is equals to minus root 3 plus I. Think once, then I will start. Think. So over here, A is minus root 3 and B is 1. The coefficient of I, that is B, it is 1. So first of all, we need to calculate modulus, that is Z, equals to under root A square plus B square. So it will be under root minus root 3 to whole square plus 1 square. Under root 3 square is 3. 3 plus 1. So it will be under root 4. Under root 4 is 2. So value of modulus of the complex number is 2. This is also said as R. After that, we need to calculate theta. So for that, tan theta is equals to P upon 8. So tan theta is equals to 1 upon minus root 3. This says that tan theta is equals to minus 10. 1 by root 3 is 30 degree. Pi upon 180. So pi by 6 radian. Now A is negative and B is positive, that is pi minus theta. So it will be theta equals to pi minus pi by 6. That is theta equals to 5 pi by 6. In this question, we need to calculate only two things, that is modulus and argument. Whereas if the question is saying write the polar form, then it is R cos theta plus I sin theta. So it will be R, that is 2 cos 5 pi by 6 plus I sin 5 pi by 6. This will be the polar form. Now I think each one of you will be able to do this kind of questions easily. So it's good. This table you must be able to remember. What we can do, you must take the screenshot of this. You will be able to have everything. Okay, this will be better, na? Whole question and table. Keep the screenshot with you. So this part is over. Complex number Z1 and Z2. We have been given two complex numbers Z1 and Z2. And we need to prove real Z1 into Z2. real Z1 into Z2 will be equals to real Z1 into real Z2 minus imaginary Z1 into imaginary Z2. Let Z1 is equals to A plus IB. And Z2 is equals to C plus ID. Now try to think, A can be said as real part of Z. A is the real part of Z1. B is the imaginary part of Z1. C is the real part of Z2. D is the imaginary part of Z2. Now, as per the question, we want Z1 into Z2. So let us go for that. A plus IB into C plus ID. Now multiply AC plus ADI plus BCI PDI square. Now I square is minus 1. AC minus BD. Since I square is equals to minus 1 plus BD, sorry, it is AD. I have written by chance BD plus BCIA. I'm taking common. So this one is Z1, Z. Now this part is said as the real part and this part is said as the imaginary part. So real Z1, Z2 will be equals to AC minus BD. Now AC and BD values we are going to put. So AC is real Z1, A and C will be real Z2 minus B is imaginary Z1 into D is imaginary Z. Try to see this only was the target group. Hence proved. If they are saying you find imaginary, it is not asked Z1, Z2. Then it will be AD plus BC. A is what? Looking to this real Z1. D is what? Imaginary Z2. Plus B is what? Imaginary Z1 into C is what? Real Z2. Now I'm going for question number 4. Third we have done yesterday. I suppose you remember. Here is third. So fourth is x minus I by is equals to under root A minus IB upon C minus ID to prove x square plus y squared whole square equals to a square plus b square upon c square plus d square. Anybody could try? Then please. Prameet, I'm writing its conjugate. So let me introduce the term conjugate. Like z is a plus ib. Then z conjugate will be a minus ib. Means we need to change the sign in front of I. So making conjugate of equation 1, so it will be x plus I by equals to square root a plus ib upon c plus id. It is equation 2. I'm multiplying equation 1 and 2. So it will be x square, sorry, not x square at the first step. X minus iy into x plus iy equals to square root a minus ib upon c minus id into under root a plus ib upon c plus id. Now see, a minus b, a plus b, a square minus I square, b is y, iy, sorry, under root a square minus I square, b square upon c square minus I square, d square. This will be, now we know that very well, the value of I square is, so it will become x square plus y square is equals to under root a square plus b square upon c square plus d square. This one gives us a target to prove. This question could be done with another method also, but right now, first method I was teaching you. So that is this, and I feel this is one of the very easy method. Now, based on this, I'm giving you a question which you need to try. X plus iy is equals to a plus ib upon a minus ib. We need to prove x square plus y square equals to 1. Now you are doing this. Prabneet, given x plus iy equals to a plus ib upon a minus ib, making mod on both the sides. Taking mod this will be under root x square plus y square is equals to under root a square plus b square upon, this will also be a square plus b square. Now see, under root x square plus y square equals to under root 1, x square plus y square equals to 1. This is another method for the same question. It's nothing new. Whatever we have done in the previous question, just something as per the method I have changed. Otherwise, nothing is new. Now see one more method I need to teach you. If two are okay, one more I am doing. I feel two methods are sufficient. And keep in mind one thing, whenever I'm teaching you a particular question with more than one methods, like this question first I have done with one method, then I have done with another method, now I am doing with one more method. Don't feel that every method you must be doing. As a student, we must be knowing one of the method which we find is the best. So we have been given x plus iy equals to a plus ib upon a minus ib. Let us rationalize RHS. Rationalizing, you know very well, na? Whatever sign is in denominator between the two things, opposite to that we need to multiply and divide. Now denominator will become a square minus I square b square is equals to a plus ib to whole square. A square, I square is minus 1, so it will be b square, a square plus I square b square plus 2abi. I square over here also I'm putting minus 1, a square minus b square upon a square plus b square plus 2ab upon a square plus b square I. I've taken separate real and imaginary part. Now, if I am going for its conjugate, then its conjugate will be x minus iy equals to a square minus b square upon a square plus b square minus 2ab upon a square plus b square. Now again same step, multiplying both the things means it is as equation 1 and equation 2. So what we will be going to call it x plus iy into x minus iy equals to a square minus b square upon a square plus b square plus 2ab upon a square plus b square I into a square minus b square upon a square plus b square minus 2ab upon a square plus b square x square minus I square y square is equals to a square minus b square upon a square plus b square to whole square minus 2ab upon a square plus b square I square to whole square. It will become x square, I square is minus 1. Na? One mistake I have made that I must show you. This I square I have written, it was I. So it will be a square minus b square to whole square upon a square plus b square to whole square minus 2ab to whole square upon a square plus b square to whole square I square is minus 1. Now I'm taking LCM a square plus b square to whole square a4 plus b4 minus 2a square b square whole square. Cancel 1 equals to x square plus y square. This was to prove. So for a particular question, we have done 3 different methods, and I think you will be able to do each question with these 3 methods. Similar type of questions. Now I'm giving you one more question. Now it's you who need to solve this. It is question number 11 on page number 113. It is a plus ib x plus I to whole square upon 2x square plus 1. We need to prove a square plus b square equals to x square plus 1 to whole square upon 2x square plus 1 to whole square. Ramit, this question also you need to do. They are similar. Whatever method you want to implement, that is up to you. 3 methods I've taught you.